Output mode switching for parallel 5-bar manipulators using a graph-based path planner. The configuration spaces of parallel manipulators are more nonlinear than serial manipulators. Here we visualize the configuration spaces for a serial 2R on the left and a parallel 5-bar on the right. Both provide a mapping from input angles, phi psi, to an output position, xy, and both have configuration spaces that could be viewed as smooth manifolds using only 3 dimensions. These manifolds are visualized in x, y, psi. When projecting them onto 2D, everywhere the surface turns back, forming smooth fold shapes, this casts edges onto the 2D projection plane. Viewed in 2D, the configuration space is no longer smooth, and the casted edges form curves of singularities. In this 2D projection, the singularities form boundaries where the mechanism could configure on one side, but not the other. When the 2D projection plane is chosen to be the output coordinates, xy, then the projected edges are called output singularities. When the 2D projection plane is chosen to be the input coordinates, phi psi, then the projected edges are called input singularities. At an output singularity, the configuration is at an internal or external bound of the workspace, and the semi-axis of the velocity ellipse normal to that bound collapses, offering a reaction force in that direction in the absence of input torques. It is important to note that output singularities do not suffer from force transmission problems. At input singularities, the configuration is a bound of the input space, and the semi-axis of the velocity ellipse tends toward infinity. In that direction, the manipulator is unable to exert force. At input singularities, the mechanism suffers from force transmission problems. Now let's zoom back out to higher dimensional smooth configuration manifolds. Abstractly, we can compute the locations of input and output singularities and use these to partition the configuration manifold. Sections that are accessible without crossing an input singularity are termed input modes. Sections that are accessible without crossing an output singularity are termed output modes. Our path planning method constructs a graph representation of the configuration space and solves an optimization problem over all edges to determine transmission quality and remove input singularities by a margin. A graph-based path planner is employed to bridge output modes within a single input mode. We applied our method to 2 examples. For our first example 5-bar, we select a workspace that has 4 real inverse kinematic solutions. 2 of the solutions have velocity ellipses with semi-axis lengths at a 4:1 ratio that are perpendicular to each other. Switching between these perpendicular ellipses involves traversal over 2 output singularities. Our second example 5-bar displays interesting output singularities that form a loop-to-loop. In one output mode, this workspace bound acts as a ceiling, and in another, it acts as a floor. Once again, to move between these 2 output modes involves crossing 2 output singularities. Thank you.